All right, so we're going to do problem 45 here. If you look at this problem, follow along your books, since I'm not going to be able to have both my work and the problem up at all times here. But on 45, it says two bumper cars move in a straight line with the following equations of motion. And first asks which car has the greater speed, and at which time do the bumper cars collide? Sorry. Okay, so the first question is really pretty simple. We look at car 1 there, equation negative 4 meters plus 1.5 meters per second times t. So that means it has a velocity or a speed of 1.5. Car 2, its equation of motion is 8.8 meters plus negative 2.5 t. That means its velocity is negative 2.5. Okay. So it obviously has a higher speed, 2.5 versus 1.5. So that answers our first question. Question B says, at what time do the bumper cars collide? Now, for that, okay, when they collide, that means that they're going to be occupying the same space at the same time, meaning they're in the same position. So if you follow me along over here to where I'm going to be showing my work, okay, we write the two equations. I get a good angle view. Okay, write the two equations. X1 is equal to negative 4.0 plus 1.5 meters per second times t. Second equation, x2 is equal to 8.8 meters plus negative 2.5 meters per second multiplied by t. Put these in parentheses here so we're a little bit more clear. There we go. Okay. Now, we're asking when these two vehicles are colliding. They're colliding when their positions are equal, which meaning that the position for car 1 is equal to the position of car 2. Okay. Now, if you think about it on a number line, just trying to conceptualize what's happening here. Okay, we're on a number line. We have position 0 there. Car 1 starts at a position of 8.8. So let's say car 1 is here, and that's at a position of positive 8.8 meters. Car 2 starts at a position of negative 4.0 meters. This is, that's car 1. This is car 2. Now, car 2 is headed in the negative direction at 2.5 meters per second. Car 1 is headed in the positive direction at 1.5 meters per second. Again, this is going faster. This is going slower. Obviously, they're going to collide somewhere in the middle here. This question asks what time. So they're going to be at the same position. So x equals 1 equals x equals 2. So that means that this whole equation can be set equal to this whole equation. And they're asking for time. So if they're asking for time there, then we can just set those equations equal to each other and solve for t. So setting them equal to each other, we have negative 4.0 meters plus 1.5 meters per second. I forgot the units up here. Times t are equal to 8.8 meters plus negative 2.5 meters per second times t. Okay, get like terms together, combine all of the t's, combine all the other terms. I'm just going to take all the t's over this side, so plus 2.5 meters per second t plus 2.5 meters per second t. So I'm going to take all the t's over here. I'm going to take all of the other numbers over to the other side, add 4.0, add 4.0 meters. Okay, that cancels there. That cancels there. Add these two terms. That gives us 4.0 meters per second times t is equal to 12.8 meters. Then in our last step, divide both sides by 4.0 meters per second. Divide by 4.0 meters per second. And when we do our math there, t is going to be equal to the answer to this, which is 3.2 seconds. And that's our final answer. If we had a different question that asks you, well, at what position do they collide? Going back to our number line here, what is that position that they collide at? If we had to solve that problem, all we had to do is go back down here, take this time, plug it into either of these two equations, plug that time in there, and solve for the position that they collide at. Regardless of which equation we plug it back into, it's going to wind up giving us the same position. Because when they collide, they're going to have the same position at the same time.